So this is what we have so far. We've created this validator class that has these three methods that convert string to integer, getInt and getString. And in all of these cases, we're trying to handle any possible errors related to user input in a protective manner, trying to validate every possibility. And because this validator so far is designed for console keyboard input, I think what I'd like to change with respect to this getInt, just a small change, is that I'd like to create an integer and name it result right here, and use the scanner to get the integer, and then return this result as a separate step. So this gives me a chance to eliminate new line character from the input buffer. So in this case I would say eliminate new line, right? New line is a character from input buffer, because I know that we're dealing with keyboard input using the console style input, and the next integer will be generated as soon as the user hits an enter key. And so there is no reason to keep this new line in the buffer. So it's good to eliminate it right away, going back to our scanner object, and then return the result. So you see that now that we have as many as 4 lines in this try block to try things and see if they all succeed. But if something goes wrong, we give the user the prompt, eliminate any non-numeric input, and go back to the prompt. So this is an example of dealing with this input mismatch exception that is possible to get from the scanner class. So we discussed in general the syntax of the try and catch. So these are more formal version of it in the handout. So I'm just going to move over quickly. Input mismatch exception, we just experimented with this type of exception. So once again, I'd like to forward to the next slide, and you can see that we can import it, but I used it without import, because when I get my exception stack traces, I can just copy and paste the entire reference to the class inside Java library and reference it this way. Okay, so that will stay just the way it is. I think it's fine. You don't really have to always import everything from the library. So this is an example of getting a possibility of next double exception. It's very similar to our next int numeric input mismatch. So that's just fine. So the catch block can handle multiple types of exceptions. We will study this form of try and catch in the future when we will start building our own exception classes. For now, I just think that in our practical examples, it's quite enough to have just a try and catch statement with a single catch clause involved, but you can have multiple exception types in the try and catch. Why would you need something like this? Because sometimes when you deal with complicated library objects, such as, for instance, you want to deal with the file system, there could be a variety of different kinds of possibilities. You can have a problem with the path to the file. You can have problem with the name of the file. You can have a file which is read-only when you try to write into it. So there could be numerous ways to get into error condition when trying to work with objects on the file system. So this is why here's an example of file not found, and also input-output exception, which is more general exception, like when you try to process something on your hard drive, but then the hard drive runs out of space and you just get generic errors that you can no longer work with or write into a file on the system. So these are possibilities of having a try block with multiple catch statements. So there is a third type of block available within the try and catch statement, and it's a finally block. Once again, when we design our own exception classes, we'll explore the finally block in greater detail. For now, it's just enough to use try and catch simple structure to handle errors that we may need to handle at this stage. So the scanner input can also be validated in a different form rather than handling input mismatch exception. And I'd like to show you how to use, for example, hasNextInt, just one of these to demonstrate in the attempt to rewrite getInt using a different logic.